Okay, so in the last video we were done till the lock and key model, which was introduced by Emil Fisher in 1898. In today's video we are going to look into induced fit model. So this was introduced by This was introduced by Koshland in what year? That was 1959. So just let me give you the concept of this model before with the diagram. So if we have this one as an enzyme, this is enzyme, and the upper one which attached with this one is substrate. So for this, of course, we need to have any of the substrate which would be like this in the structure. But wait, this, if we attach this one into this on the upper side, this will known as lock and key. This means for a particular enzyme we have particular substrate. But what? So now what is difference between these both? So for this, if I'm attaching this as a substrate, this is round like a structure, like this is not particular in shape. They both cannot, like these both can really not attach. So what does induced fit model say? The Koshland said that if we have the other substance, other substrate and other enzyme, still for that this enzyme will change its shape. How will they change its shape? Okay, if this was the enzyme, if we need to attach a circle shape, so its shape will become like this, and we will be able to attach the round like structure in this. This is again known as substrate, this is enzyme. So what does exactly said? That in the lock and key model we were suppose that every particular, there should be particular shape, particular structure to be binded. But in this video we will have enzymes which will change its shape, its structure, so that substrate could attach at this one position. Okay, so now let me just write it. What this said? This said enzymes, no particular enzyme, sorry, no particular shape, no structure, like they have a structure but not particular structure. So this means if we have the enzyme, enzyme will change its position. We can write enzyme will change its shape and structure, so that the substrate could bind with this one. And they, like before, like these are in the inactive form. Before they would be inactive, but at a time they got cofactor or they got the substrate, they will get activate. Then active form. Okay, so how? If we have this one as enzyme, this is in the inactive form, this enzyme is in inactive form, but when this substrate would be attached, this means it have to change its position, so this will come in the activation, the active side. Okay, I'm sure you are getting the concept. So the biggest difference between lock and key model and induced fit model is that they were saying that it cannot change its shape. The Emil Fisher said it cannot change its shape, but when Koshland came in 1959, he said that enzymes are supposed to change its shape, its structure, so that they could bind. Otherwise there would be no binding between them. How could they attach? Not every particular shape, structure is there in the enzyme activation. So for that we need to have a particular, not importantly, we need to have particular shape, structure. Okay, so we can say in that one the active side was rigid. Active side is flexible. Rigid simply means, wait, okay, so in this one, if we have this one as an enzyme, okay, the side, that this one side is known as active side, this one is known as active side. In the lock and key model they were not supposed to change its shape because substrate should be attached, but in this one they are flexible. If I've added this, so this enzyme will change its shape, that's why this active side will change its shape. That's why these are known as flexible. So active sides are flexible and these are also known